And good morning. We're gonna get to it soon. Really soon. Hope everyone's doing alright. Alright, that's gonna compile, and speaking is hard for some reason. Compile. That's hard to say this morning. Alright. And I have a little delay. So if I turn that off, oh, that's better. Okay. Yeah, having that feedback there, it's gotta be like 50 milliseconds. That makes it hard to speak. Okay. Hey, Xenocron. Yes, we got a new mic. New mic. It's new mic day. Yes. I've been waiting for this. I wanted to get this not just for this, um, but to also do the recordings for the game. So I'm gonna do some voicing for the game. I'm gonna have my kids do some voicing for the game. We'll see how it goes. I don't know, what do you call it? Voiceovers, voice actings? It should be good. Then I was trying to kind of mess around with some of the settings here. It's alright. It's alright. And I think I want to get a monitor headset because right now I can only hear the music out of this. I can't hear myself, but that's okay. It is a condenser microphone. This is Audio Technica 2035. I think I got that right. One of my friends actually does voice work. We were both engineers together at Microsoft, and he ended up uh, becoming an actor after working at Microsoft. So, well, while working at Microsoft, and he does actual voice work. He uses this one here, not this exact one, but this mic. So how could you tell that it sounds that it might be a condenser microphone? Yeah, man, he's like really high energy though. He's super cool. That files. Oh, you know what? We gotta wake Captain up. Just a minute. Just a minute, Vlad. Actually, we're almost there. Yeah, Capitan didn't. I had to rewire everything here because I moved my desk again. Nope, wrong one. There we go. Huh. I was flipping between the two mics, and this one captures so much more. It does. All right, Vlad. Should be there. Oh, you're welcome. You're welcome. Made a couple of those. Okay. You can also download it and compile the latest weekly for Rust Analyzer. So we'll see how that goes. The font seems a little large today. Um, we'll see how long we can go with that. Then the past couple days, I was having health issues, so I wasn't streaming. So thought it might have been gallbladder related, but yeah, they say I'm fine. So I just got to tell the pain that. Actually, no pain today and yesterday. So who knows? It could have been something like I don't know. They were telling me, okay, well, in that case, it's either like is it like acid reflux is causing some issues. So don't drink before bed. Don't drink alcohol before bed. So they say that relaxes the muscle at the top. So now I have to move all of my drinking up to noon. Perfect for afternoon coding. Yes, yes. Oh, and also we have yeah, breakfast beer. That's right. All right, but I wanted to show you the Starlink things. Here, where'd OBS go? I lost OBS again. Big webcam. All right, let's see. Oh, no, no, no. Too much light. Anyhow, we'll just one moment. Turn the brightness down. Better? Oh, that's a lot better. All right. So you can see it's doing incredible. It's hardly any drops. I'm not using Stitch. So I've only had 55 seconds of downtime in the last 12 hours. Speaking is hard. Yeah, no latency. Oh, that's awesome. I've had 17 drop frames. That could have been a compiling thing. Rendering lag. So far so good. All right. And audio levels okay today? I mean, we're going to edit border box because we need to change how our borders work. Where is it? In here. So I'm going to subdivide our borders. There we go. Third time's the charm. New file. Sure. Yeah, that's right. Let's just keep hitting cancel. All right. So right now, our boxes, let's see, let's go to 100%. And fill it with whatever that color was. Okay. 100%. Let's use some chalk. And I'm going to freehand this, so apologies in advance. So right now we have our beautiful rounded rectangles. We draw them clockwise this way and then counterclockwise this way. And we might have sharp edges, we might have kind of round edges, thick borders, thin borders, etc. Okay. Now, if you remember, we were doing some shading on these, and we don't have enough vertices to do everything we want. So in order to create some vertices, let's see, that one gets drawn that one. This one gets drawn counterclockwise. We have to subdivide this into fewer shapes. Well, into more shapes. Now, how do we do that? What are we working on? Quentin, good morning. We're working on changing some of the way. How do I say this? We have some UI elements, and those UI elements have they're tessellated, okay? But the vertices from the tessellation aren't exactly where we want them. So we're going to make the shapes smaller. Well, not exactly smaller. We're going to slice them up. So like here, 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 here. So that we can control where the verts are. And if we have control over where the verts are, we will be able to do the shading on the shader and create a very smooth effect. Because right now we don't have the verts everywhere we need them, and the effect is falling apart. So what do we do here? Let's see, that might be a little too loud. Okay. We can actually pull up Godot. Let's see. Oh, it doesn't want to do that. Okay. We'll go to top view and normal wireframe. There we go. So these are some of our rounded rectangles, quite flexible. If we go back to wireframe, you'll see over here that we don't have enough vertices where we want them. I know you probably don't know what we're expecting here. So what we're going to do instead is break these up into the corners, the segments. So I'll have the 4 corners, the 4 segments, and we should be able to better control where the verts are in the segments where we want them so that we can apply some more shader effects. So right now we're dynamically adding UVs to these, but we don't have enough vertices to put the UVs exactly where we want them. All right. Okay. Oh, that's constraints. We want, what is it, render? No. Render. Render. All right. Now, let's see. Did I miss anything? No. So we have render. Now, per our incredible drawing, the outer one, right now we draw 2 rectangles. The first one on the outer racetrack is drawn clockwise. The inner one is drawn counterclockwise. Now, if we're going to split that up, we can't do that. We're going to have to first draw the corner, close it, come back, like so. So we'll have to first draw this section, then the next section, followed by, you can probably guess what's going to happen here, the next section, and so on. So we're going to break that up. Etc., 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 until we get what we want. Which means that our path builder, which is currently, where is it? Oh, that this here doesn't. We were trying to add these points after the fact. It didn't work. So we can get rid of this. Thinking about actually attaching the other monitor to this to the same box. Because of the new mic setup, I can't see when I'm muted anymore. I used to be able to see it by hitting the little mute button on this thing, but I can't see that anymore. Let me rearrange just real quick. So I don't want to cough into the mic. That would be awful. Hotkeys, I'm using hotkey, but I can't see if what the state is. So if I miss, hit the wrong key. All right. No. So we're going to get rid of this. That's gone. We still use that. Still use that. Good. I think we're going to have to create another trait here. Instead of like add cubic rounded rectangle, we'll have like add awesome rectangle. It does mean that we will need more of these. We'll also need corner sizes and the inner rectangle. So this rectangle, these corner sizes, corner centers, we'll need all four. So now the first piece, let's say we don't do that there. We should be able to actually return a value from this. Border rect and border radii. Border radii. Semicolon there. So we'll save that. Okay. Now, just, it's too much. It's too much. Mismatch types. All right. Now we'll do the same thing here for inner rect. Inner, what do we call this? Inner corner sizes? Corner centers? Is this just a bad name? So I think that is a bad name. Oh, look at that. Hotkeys for commenting. That's so cool. All right. Corner centers. Now we'll have the rectangle and the corner centers. Now we need a path builder. Draw. Let's say add awesome rectangle. We'll pass in the four things. Add a rectangle. Anything else? No. Now we just need that. Oh, that's right. Let's get rid of some of these. Although we might be able to use midpoint. Although I don't think it's the right midpoint. So how was your weekend? You guys have a good weekend? I hope so. I had an alright weekend. It's kind of relaxing. Just chilling. It's getting light early. Oh, and I mounted the Starlink dish That was last week. I think I already told about that. But in case you didn't hear, it's no longer on the lawn, which means that the goats will no longer climb on it. Yeah. So I was in the middle of a work meeting. Internet, boom, dead. Like, what? Why? Usually it came back, right? A couple seconds later, it'd come back. It never came back. I'd go outside, find the goats sniffing it. They're like, hey, what's going on with this thing? Had to put it back up, power cycle it. It had gone into like a motor's stuck mode because they had Dishy McFlatface face down in the dirt. Poor thing. So Starlink versus Goat Herd, not even a competition. Oh yeah, they get bored. They eat things. They climb on things. That and they destroy their fence. So I got to rebuild their fence, which I'm not looking forward to. I need to find a trailer that can haul 16-foot panels. I don't have. So this code here, this should go back to the way it was. Because what we did there didn't help. All right, that one's back. We left midpoints in there though. Just a quick check. This isn't very bad. We had been getting an order of magnitude worse there. So that's not so bad. Okay. So we're going to impl draw awesome rectangle, which means we need a trait for that. No. Bug trait. Add awesome. Do we need a mutable self? Yes, we do. Add a rect. So we're actually taking both of these. So we're going to take this and then this. We do not need the winding. We'll control that. Yeah. Now back to here. No code action available. Lies. Oh, 4. What are we adding this to? Okay, it's a little too far down for builder. Okay, let's move that up. Oh, I'm trying to find it again. Just at the top. That'll work. All right. See, that was close. I actually went to go mute myself on the old controller. That would have surprised you. Um, all right. There's our to do. Now, I think the corners are fairly obvious, right? One, two, three, four corners. But how do we do with the other pieces? We could go ahead and do this piece. That'd be fine. What about these? We might want these to be two things. Yeah, what do we do for those? What do we do? Oh, and I'm also going to use this for work now. It's going to be awesome. A little coding ASMR. If I turn off the remove noise, get a little clickety clack here. Now you can hear everything. I'm using Crisp. Crisp helps remove all the background noise. Not like this. Actually, Crisp works really, really well with this. Yeah, without a noise gate. Because I don't have a noise gate. I'm just using Crisp. All right. Let's do the first rectangle. Now, how do we... Let's start from here. This will be our starting line. We'll come around to that point. What were we doing before? Yeah, before we just add curved rectangle. Hmm. 5 a month? I actually did the yearly because I use it for work and it helps so much if I have kids around. I figured, you know what, it's worth it. It wasn't worth it before. Before they were trying to charge like $20 a month. That's outrageous. At $20 a month, I'd rebuild it. Then I would like to still like I wouldn't mind making that a project to do because I would rather train it on my voice, not everyone's voice. All right. Yeah. See, we're just gonna have to do cubic Beziers for everything. But to do cubic Bezier, we have to come up with a control point for this. So we might actually go into the other source code to see how we did that over there. All right. So what's our first point going to be? First point's going to be this one out here. Then we'll have to draw this outer corner. So it's going to be the outer rectangle minus the outer radii. Because I believe the radius here is supposed to control this whole thing. This, if you can't tell, is supposed to be one big curve. I know it's not obvious. So I probably could have done it better with like this. See, some awesome curve. So we'll go around there. Then we'll have the inner rectangle. So we'll have to then just come straight in. All right, so self dot, is it like move to? I think it's just begin. And we give it a point. All right, what point? It's going to be let start. I don't know. Now the X on this is going to be the outer rect. They have a, what does a rectangle have? Size, width and height. Should have an X and Y on there. Wow. Top left. It's actually outer rect dot Y minus that. Okay, so we'll start at start. Then we need to do a cubic Bezier 2. So we give it the 2 control points and then the end. And what are the control points? So curved rectangle's doing this for us. We have our corner points, return an array, got our corners. We could still use this actually, because if we get the points, we'll get that array, and we get the control points for each one of these. And we just won't be using it for Commander Thrashton. Good morning. Good morning, sir. How you doing? How was your weekend? Ah, you had your second shot. Ooh. For anti-COVID? I like to call it the anti-plague. Plague is just such a nice word, you know? I mean, I don't think that the plague should, like, be the last one that they held on to that name, right? It's a trophy that should be passed on from plague to plague. I'm gonna pour some tea. Sputnik. Ah, yes. oh, oh, Xenocron. You had a question. Sure, what's up? Oh, interesting. What else? Iterable? I mean, traversable foldable, I mean, what language are you thinking there? Yeah, it's the same thing there. Because the iterator type does allow for, traversing and folding and a bunch more. Interface worthy standard library. Language agnostic. I mean, usually when I think of these, I think of them in terms of languages, though. I don't know. That's a good question. I mean, just straight off, I don't have a good list. And I mean, read and write. That's huge. Disposable. I mean, yeah, I guess because most of these are language specific, right? Disposable. It's only usable for languages that dispose of things. Um, I mean, optional, right? I think that'd be a great interface. I Some of the big ones in Rush, right? Um, the return types, right? Okay and option, I think are great interfaces. If other languages had that, that would be awesome. Option, it's basically null or well, it's something or nothing. Right? So yeah. Um, and the other variant of that is when you do have an error, right? So instead of something or nothing, you have something or error, which is the result type. Yeah. Um, what else is there? I mean, I'm sure if we see it, it would just be obvious. I mean, the number types have a number of things, right? Hashable, yeah, like hashing interfaces. I mean, these don't have a lot of traits on them, but there is a crate that provides a number of traits for numbers. Future is one that I would say is in there. Serializable. Oh yeah, yeah. Then and yes, you are absolutely right. That is a huge one. That's huge. Being able to represent something as some other format. So a good example would be a Saturday. So you can serialize and deserialize. So let's say you had a structure, right? And you wanted to save it to disk. You would use reader and writer, of course, if you wanted to read and write that to disk. But then how do you represent it on the disk? I think that's really big. That's really big. Fix it. So good for storage, yeah. And one good for debugging, good for transfer. So that's a big one. What other ones do we have? Collections. Like in Rust, you have basically any of these traits, right? And so a hash map will only accept certain kinds of things, right? Things that are equal in hash. Oh, those. Oh. There's this whole list. Um, Printable. Um, can you actually represent it? So orderable. These here are good set. So print and debug are slightly different. Right? Equal, partial order, ord hash. And those are going to be the same thing. one or two. But it's an interface, and it lets you compare things that aren't normally comparable, right? Partial equals good, equal. And there's a subtle difference here between partial equal and equal. Think partial equal doesn't have, was it transitive? No, okay, it has symmetric and transitive, but not reflexive. So it might not be equal to itself if it is partial equal. An example of why one would be partial equal but not equal. That's like a float, or to float here. Yeah, not a number. It's not equal to not a number. So it can implement partial equal but not equal. It's not like cast, no. Because certain things just aren't equal to each other, right? Like infinity is not equal to infinity, not a number is not equal to not a number. You can have different sized infinities, etc. I wouldn't say that these create new objects. I mean, it could be, right? Like if a bool is an object, all right? So what are we gonna do here? What does string have? See, in this sense, they're also using the operator overloads as interfaces. Display. They even do like reverse iterator, double-ended iterators, things like that. That's kind of iterable though. Indexable, right? Can you index into it? Oh. There's a write, read and write. That's all I got. We're going to extract this here. Going to have something that lets us go from border radii into corner sizes. Oh, that's actually a border radii. All right. That'll get us close. So we're going to do the same thing up here. Oh, cannot be dereferenced. Ah, yes. Okay, there we have our outer centers. Now, what we have to do here is we're going to draw that first corner. And it looks like we have all the pieces for it because we'll have, let's see, the control points, the actual rectangle points. We'll need those for each of these, the outer and the inner. Curved rectangle, no. We need to give that the outer rect. And then the outer centers. Hmm. This isn't correct. The inner centers isn't the right word for that. Sizes is actually a lot more accurate there. Now in this case, we want same thing, curved rectangle. All right, outer and inner for both. All right. So I gotta go call the dog in. I'll be right back. Give me 2 minutes. Be right back. Ah, she was right there. Didn't have to do anything. So, we'll have our awesome rectangle. Outer and inner curves. Now we need the outer points. Outer points, outer control points. Want to do that for the inner other one as well. Okay. Okay. So we have our outer, our inner. What? Oh, it's borrowed. Okay. Should be able to convert now. Now we need winding. Ooh, that's hot tea. That's really hot tea. I'm gonna do a little check on Starlink. So far, Starlink has been awesome today. We're not even using Stitch. Yeah, it had a little drop earlier, and I saw that. But really, it's not bad at all. Yeah. Now winding. So we want this to go clockwise. That's positive. Same there. These technically are supposed to go the opposite direction, but if we do that, which points do we get there? Because in this case, we actually want the points all going in the same direction so that we can capture the first set. You'll see. Group these. There we go. Now we just want the first corner. How do we get the first corner? This is going to be the first two points and control points. And we're going to go back and split. Split that again. Oh, pass the test. Okay, here we go. Control points. Wow, this file is huge. Yeah, so normally we just go to the first point, and then we draw cubic Bezier via the two control points, ending in the second point. So we have points, we have controls, control points, and points. Maybe we should call these endpoints and control points. All right, now with that, actually, if we zip these up in just the right way, we can have a couple of iterators, and we can draw these in a loop here. So we'll do each of the corners. We'll chunk them, group them, because we need two of each time. Now in this case, and now we can see more. We're going to start abbreviating because it's going to get long. OEP. Chunks. Outer endpoints. I want size of 2 for that. That's an iterator. CP for the control points. Oh, E and C, that's awful. Now we're going to zip those together. The outer end chunks with the outer control chunks. All right. Now we do the same thing for inner. Now we zip both the outer and the inner together. For something in both. All right, now what do we have here? What is something? We're gonna have a tuple with the outer on the left, inner on the right. And inside the outer, we will first have endpoints. Outer control points. Okay, then inner. And we have to do the same trick because no, we don't actually. We always start with the self dot begin, because we will go to the first outer point. We'll always start there. Corner. So we move to that location. Now we do a cubic Bezier line. Add cubic Bezier to. Now we need the 2 control points for the outer. 0 and outer control points 1. Followed by outer endpoints 1. Okay, so that'll be the first line, right? But now we have to go in. So line into the inner curve, the end of line 2. And now at this point, all right, that's funny. Whenever I mute myself, I had F9s. That's great. All right. This will be inner endpoints, but it's got to be the second one. So number 1 there. Line to that. Now we're going to curve from there back to the beginning. And these endpoints are going to be in the opposite order. 1, 0 with inner endpoints 0 there. So that takes us back down to the beginning. And if you can't visualize it, the first one went out this way. Oh, I'm still in draw line mode. So the first one started here, drew around this way, got to this point here, then we lined into the center. Now we're going to do this cubic curve back, and then we'll line back over this way. Close the shape. Let's add a little bit more info there. Actually, do we need to come back? Because we have all of those points. Self.end. Close true. Okay, now that should give us the shapes for each one of these. But that's about it, right? Because now we need the bars that go between them. We can check this though. Here, let's. Uh, So what's going on here? Unused winding. Yeah, yeah. We want the errors though. Oh, yes. These are all borrows. And I think we have to add a little bit more information to these so that later when we're adding the UVs, we can use that metadata. We'll do that second though. Midpoints never used. Goodbye, midpoints. I mean, maybe we want that. Okay, we'll leave that there for a minute. Let's go ahead and give this a build. And hopefully it won't crush OBS. Sometimes compiling can use too much. Oh, actually, do I have that too large? Oh, yes, 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 I do. Sorry about that. All right, that's a little better. Less giant head. So we've got these values here. Let's see what happened in Godot. Oh, 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 that's gorgeous. This one's a little off. This looks all right. What's up with this one? It looks like it was good up until that point right there. All right. That looks all right. This one's good too. So whatever happened up here, why? Why would it do this? That's straight up and down. This is left to right. Ideas? Hmm. So it would have started here on the outer, done the control points. That is so strange. All right, let's keep going. Maybe drawing the bars will show us where this is failing. Good night, Godot. Ah, so those are the corners. Now we have to do the rectangles between the corners. We're not going to need the control points, just the end points. And what do we have? We have outer end chunks, outer control points. No, we want outer endpoints and inner endpoints. So we'll have outer endpoints and zip that with the inner ones. We also want these chunked, don't we? But we don't want it chunked in the same way. Because for this, we want the outer ones and the inner ones. Gaming Lucas Live, good morning. Just finished up a Macintosh. Fantastic feeling. Oh, a Hackintosh. How's it running? Do you have support for everything? It's running pretty good. Just a bit of tweaking here and there. Nice, nice. So these endpoints are not in the right order. We need to take, let's say, okay, we need to skip one. Okay. Oh, this is going to be weird. Let outer is going to be equal to outer endpoints. We need to skip the first one. Can we loop it? I thought there was an iterator thing for this. Where is it? Where is it? Skip, flatten, inspect. No, no, no. Cycle. So we'll use cycle. Then we can use take. Where's take? Here. Creates an iterator that, okay. So cycle. I want to, what? I'm going to take how many elements? 8? We only want 8. But we need to skip one in there. I'm going to skip the first one. Then we want to take 8. Okay, we need to document this. start at the second point. The outer endpoints. Now that'll get us to the top endpoint there. All right, that'll get us to this one here. So we'll have these two. Then we'll need to come back. So we can create a chunk out of that. Then we have to do the same thing for the other ones. Same thing for the inner ones. I think it's the same exact thing there. Now we zip them together. There, now we have our endpoints. Let's draw the rectangle. It's going to be the first 2 points, so self.begin. I just thought of something. Okay. Gonna have to fix this later. We actually want to go halfway here. Because we actually want to draw 2 rectangles. Self.begin. Outer 0. Now we line to outer 1. And self.line 2. Inner 1. Line to inner 0. And self.close. True. Why? That's a point 2D. Oh. Oh, we didn't chunk them. Really? So I know we can chunk here at the beginning, but not at the end? Oh, do they call it window? So we just want 2 at a time, 2 at a time. Cycle is sorted. No. Well, that's not what I wanted. So we can get chunks off of a slice. So we could either collect it and then do this. This feels bad. As lies. No? It's not on take. But if you own it, no. What do I want to collect that into? See, I didn't want to do that. I just didn't want that to happen. Okay, two different point types. Point 2D F32, unknown unit. Lion, path, geometry. Ah, so because it's borrowed? That was one of the differences. That clones the iterator. We want cloned. Hmm. But if this was a vector, you could do it. And if this was not cloned, could you do it? No, because now we have reference to a point. Which, I mean, the size of these, we might as well clone them. I don't like it. I don't like it. Let's flip it. Because we have these points here, right? And these are, it's just an array. It's on the stack. Yep. That goes away. That goes away. Fanciness there. Gone. For X in. We're going to start at 1, 3, 5, 7. Oh. Let's be explicit here. A and B. This is A, B, B, A, close. So there'll be a 1, 2. And if we draw this out, we'll have 1 and 2, 3, 4, 5, 6, 7, and 0. I don't like this either. Let's do 1 dot dot. No. 0 dot dot 7. 0 dot dot 8. Inclusive 7. Cycle. Skip 1. Take 8. There. Oh, but now we need the chunk. Now we need the chunk. Or window. I wish. Where is window? It's on slice. All right, it's got to be on iterator somewhere. But where? I basically just want 2 at a time. I want the same thing. Filter, take well. Reverse, no, no. What we could do is step by. Intersperse, of course. Nightly only. We'll skip that for a bit. Iter tools as tuple chunk. Oh. I think okay. Favalor. How do you say this? Favalor? Bedios? Do I call you Favi? Or just Favalor? Favi. Oh, I see. Favi or oh. Okay, I just totally split that at the wrong part. Favel. Good morning, Favel. You know what we could do? We only do snake case around here. That's right. Actually, did that show up different in? Oh, I see. Yeah, it's actually different in chat over here. Huh. Okay. The display name's different than the other. Gotcha. Yeah, let's see. Because here you can see it's the right case. But what else could we do? We could, instead of pulling in that crate, we could implement tuple chunk. We could do that. What about just doing a map? All right, dot map. Or just map it into something else. But we want the last one to go back to 0 because we want to start at 1. Right? Oh, tuple windows was the function. Gotcha. That makes sense. Oh, wow. It's used so much, but it doesn't have a README. It's astounding. Ah, you got the double paste. Oh, wow. Look at all these. Tuple window. Up to 4. Huh. How much you need is tuple? All right. Hmm. All right, we're gonna do it. AK dot tuple windows. Can we say that this should be of size 2, right? Oh, what's the difference between chunks here? Yeah, just saying hi. Good morning. All right. Panics if size is 0. Okay. Tuple windows. This song's a little loud. Okay. So tuple windows. Returning the iterator over all continue. Ah, yeah, we don't want that. We don't want window. We actually want chunk. All right, what is that? That's just called chunks. Perfect. Gotta restart COC whenever we add something like that. Now we have to use this. Oh, interesting. Into chunks is iterable, only by reference. Huh. Isn't that the same thing, though? I mean, is that implemented on this kind? I doubt it. This might not actually work because unless chunks is actually, say, trait iter tools, what is it implemented on? Hold on a sec. All right. It's based on group by. It's iterable. All right. All right. Where were we? Oh. Did I do that at the wrong spot? I don't think we actually need the intuitor here. Oh, it's not an iterator. Okay. That should also break then. Let's give that 10 seconds. I'm going to drink some tea. Yeah. I think I have to change this a little bit. How's this? Testing, testing, testing. Okay. So that still doesn't work. Why? Why doesn't that work? If we do chunks on that, that should get closer. Trying to sit up straight. Testing. Give me just a moment. Testing. Okay. So hopefully this is still coming through okay. I'm going to listen. It seems a little soft to me. It seems really low. It's probably just because I have my audio really low. Okay, give me a technical moment. Where'd it go? Loop back. Where are you? There you are. I'm gonna kill the audio for a moment. No, that didn't do it. Pretzel, chill. Thank you. Okay. Okay. Once again, testing. Okay. Testing. Trying to dial this in because I had to lower the mic. Just trying to get some background noise. All right. That should be okay. If it does get too soft, let me know. Spending way too much time on this. We're doing this. 1, 2, 3, 5, 6, 7, 0. Look at that. Stuff that close. Expected 0 arguments, found 1. Why? Why is that? It's end. I guess all of these... we didn't have to begin and end so many times, did we? There we go. I'm going to try to dial this down even further. A little experiment here. First day using this, so bear with me. Okay. How low can we go? All right, I think this is the max I can do there. So let me dial this up. Testing, 1, 2. Test, test, test. Testing. Okay, that's a little too high. I think we can deal with that. I would expect a point. Of course, this is going to be outer A, right? Then we have outer B. And then inner A and B. There we go. That was a really long... How was that? 20 minutes? 30 minutes? Just, wait, why is it... It's outer endpoints and inner endpoints. I... Okay. That should work. Reference to an I-32? Thought we did into inner on this. Gonna have to get a little more comfortable with this. It's definitely a change. I know they added into it, or was it in 5.1? Iter works. Cannot be indexed by the borrow. So we either do that or we say copied. Those are just tuples of numbers. There we go. Okay, let's test it. All right, Godot. And I left myself on mute. Sorry about that. So we're back to where we began, but now with more segments. Thank you, Favel. Okay, that looks pretty good. Let's come back to the code. Actually, close down Godot. Let's not spin the cycles on that. Okay. Now, instead of one score box in the middle, we're going to draw two. So we need to know the halfway point between these. Midpoint A is going to be... Oh, we can't just get a midpoint from this, can we? Let me see. If we subtract the 2 and then add that to a, would that work? And can we do that with point? Does point even have that? Okay. Let's go look. Not there, not there. It's a point 2D. This is a Euclid point 2D. I'm not right on that one. That must be a Leon. It's actually Leon geometry, not peon. Geom. There we go. Point 2D. All right, there's point. But it goes to Euclid. Look, there's Euclid default point 2D. Find Euclid. Distance 2. That's not what we want. So yeah, we can subtract. And if we subtract another point, we get what? Output vector 2D? All right, so actually that's not right. We're gonna have a. We'll leave those. We'll leave those. A, B, C, D. Then we'll have some other value for the inner ones. Okay, there's our A, B, C, D. Now we want midpoint 1. It's going to be between A and B. B minus A. It's going to be A plus B minus A divided by 2. What? The type point 2D cannot be indexed. Inner endpoints should not be that's fine. All right, let's give it another save. Maybe it's just confused. Oh, we redefine A and B. There we go. Midpoint 1, and then we need midpoint 2. C, C, and D. And then we're just going to draw 2 boxes. The first box and a second box. So the first one's going to be like the first set of points. The second one after that. And at this point, we're going to begin at midpoint 1. We're going to line to B. Come back to C. Self dot. Line to midpoint 2. And then we end. Build it. There we go. Oh, there we go. We got midpoints. Oh, look at that. Beautiful midpoints. I'm going to forgive this one being in a diagonal because this is a bit of a special case. That's good. Oh, I like that. Oh, that makes me happy. That makes me so happy. Okay. I'm going to close that. Let's see. Get UI. Yes. I'm going to add some stuff here. Whoa, whoa. We don't want that. We didn't use iter tools, turns out. Okay, we need to remove iter tools from there and there. Yes. Where else? Here. Yeah, we don't want that. Anything else? That's good. That's good. Okay. Commit. How many pieces is it? One. So 4 for the corners. And 8. So 12 pieces. All right. Bad credentials. Oh, I rebooted. All right. What next? Now back to the shader. Okay. Shader's going to be good. Looking forward to this. Oh, almost. So close. So close. We need the UV to be right. Because the UV is not right yet. We might get close, though. Let's see where it goes. Um, gonna go back to GLES2 mode. It runs a bit faster, and I want it to work in GLES2. Just so many more devices. Top view. It's pretty close, but it's not right. So why is this one so dark compared to the others? I think we were doing left to right UVs. Wait, which one was it? Path UVs? I don't remember which one we were using. Let's see, this one? Okay, that one's definitely on. That one's dead code. Okay, so it must be this create path UVs. So for every point, let's see, vertex UV. Oh, here's the rest of it. Figure out which quadrant it's in. All of that again. Oh, that that one's. This is giving me a bit of anxiety. Like getting this right again. Because our left point is not right. It's just not. We know we have a midpoint over here now. We're going to switch back to GLES3 so we can make sure that the midpoints are there. See, there it is, right there. Normal, and it is not dark. It's actually gone bright. Why is it bright? Let's check the shader. I think the shader's just doing a pass-through of the value. So yeah, it's uv.x. Yeah, look at that right there. Why? I think that would have fallen into quadrant 3. We want that and the vert. Yeah, let's restart that. Give it a build, restart it. Get that built, run it. And where does this one exist? This is at 1, 2, 3, 4, 5, 6, 7. So that's 0, 1, 3, 4, 5. It's like right here. X is 3. Why is X 3? This should be close to 0. 0 would be halfway through. Maybe 0.3, that's like a third of the way, right? 1's over here, 0's on this side. 0.3 is like over here. I resized it. Here it is. Oh, and look, further down, it's actually lower value. Okay, so this is not correct. Correct. We're gonna add some test code. So let's say we're at, let's see, in this example, we are in a square of width 10. It's not quite a square. This is a rectangle. It's 20 by 10. Width is 20. Oh, no, this is fine. It is 10. The center's at 5, 5. Width is at 10. That looks fine. Okay. Now let's say we're at 0, but not all the way down. Let's put ourselves at like a not the bottom left corner, but just below halfway. All right, just on that side. That test was making sure that the corners are correct, but not the other values. So we're just gonna check a couple more values. That should not have passed. Oh my goodness. That is not that value. That should be like 0, 1 or something. X is 0. See, this one here is bottom left. And this one's top left. Oh, it doesn't have a test on it. Ooh. Is this one broken? All right, well, let's try it because we have the vertex to UV bit. Ah, yes, we're not using vertex to UV. That's dead code. Oh, no. We are using it. Fine. Cargo test. No capture. Where does it fail? It's too much information. Vertex to UV failed. Why? Why did it fail? Jobs one. Oh, wait. Okay, now where did this one panic? Border box. 618. That's not where it panicked. Where did it panic? $7.15. Oh, so the top left one failed. Bummer. Okay, this test is just bad. I'm gonna leave it for now. We're gonna set up our test over here instead. Same thing as before, but this one should be a size of 20. Yeah, rectangles width 20, height of 10. Minus height divided by 2. So we want the half height. Do we have a value for that? We do, half height. Minus 0.1. It should be some very small value then as we approach 0. All right. $6.98. Where's $6.98? Oh, don't do that. All right. So we give it this terrible value here. It should have been something like 0.0 or something very close to 0. So this was our value. They gave us 0.32, which is much too large. That's going the wrong direction. So we're not even close for that, for this quadrant. What else did we see in here? Yeah, vert. It's fine. W is 20? Why is W 20? Let's go see. Yeah, you can see that X is wrong. W is 20. H is 0.01, basically. So we're taking away from the value 1. So width and height divided by half track. So we need the full distance around. So how far have we gone from the value on the right? In this case, let's see. If our x is 0, our x was 0, wasn't it? X 0, y negative 5.1. So the width minus x. So it's 20 minus 0.1. Does that seem right? Oh, minus 0. 20 minus 0 is 20, yes. That seems accurate. Because it's the full length of the bottom half. And that's what we want. The height. Negative vert dot y. So what is h here? So this will be 20. Minus half height. Oh, and we're not adding to that. Plus a half height. Because of the right side, the far side on the right. Which means it's just that. Because we're basically saying this point over here is 1. And then it's the distance traveled to 0. So that full half height, and then take away the other half height. This will be something like a negative 5, right? So now it's a positive 5. But we should add the half height. Yeah, it shouldn't have been subtraction earlier. Because we're negating this one, taking it from negative to positive. Okay. Again. All right. So this failed at 687. 687. Ah, the one before us. We got our sign wrong. Okay. So we have half height. And then minus that. Does that seem right? Because I mean, the value that comes in is it's a negative 10. Basically, I have height plus that. Do we not have height? Oh. No, that's not right. Should basically be, let's see, what should we have? We should have, wait, we have two Godots going? That's bad. Okay, so from here, so we have height and height here. So that's two of the half height, so full height. And at this point, they're full height down. I see. So it should be the full height down plus. Oh, this is a mess. Basically the full height minus the parens will help. Testing again. Testing. Oh, goody. Okay, so that actually picks up a little less. I can drop this down. How about now? Test. No. Okay, I went the wrong way. There we go. And we're back. And what did we get here? The right. Oh, look, that is a very small value. That looks better. And we ended up at 698. Perfect. Yes, good. And that looks like a reasonable value to put in there. All right. What about the right side? Is the right side correct? Let's toss another one in there. Should basically be a 1 minus that. Oh, and it failed? Yes, good. 1 minus that. Looks good. So that's correct. Now let's do it just above right center. Is above, let's say half height plus this, should give us the same value. And same here, just below. Oh, left and right, we're not equal. Oh, that's right. The one value here, that's what's wrong. And it's absolutely correct. Because it should be on the top versus the bottom. Okay, so that's 709. 709. This one. This one. It matches this one here. And down here, this one should also match. Oh. No, they don't match those ones. Above left center, that's on the top half. So that goes there. Below right center, that's a 0. Above right center, that's 1. There we go. 1 is on the top half, 0 is on the bottom half. I adjusted the wrong value. $709. There should be 0. Now I'm gonna have to go check because I thought it was the other way. I thought it was 0 on bottom, 1 on top, but if, I mean, why not have 0 first? Why not 0 on top? Let's go validate that. Oh, quadrant 0 and 1 have a y value of 0. Okay, that's fine. Just above right center. That's 0 then. Above is 0, below is 1. Above, below. I'll get these right eventually. Eventually. None failed. Perfect. Let's give it a build. Restart Godot. So once cargo there on the right is done, we will start Godot. Well, that looks much better. You can kind of see the gradient already on this. Display normal. Ooh, look at that. Light to dark. It's not quite 0 due to the size of these. Maybe we should have it split exactly in the middle. But what if a curve goes beyond that? We could take that into account, but because it is possible for like the top left curve, that top left corner to be very large. So we could just, you could do this. Then where do you have it, right? If we go back to wireframe, it's silly that that's still 0 there, because that's not true. Oh, it is. It is because where the vertex is. Because it should be 0 down here. Ooh. Oh, that's complicated. Let's leave it. Let's leave it. You can see if we get it right near the middle. It's like this black value. And only when you get that up closer does it become black. Hmm. I think for us, this is going to be okay. So if we just say this is 0.2, like so. Radius will be the same on all of them. Just a 1. I'm a little disturbed by how fast this actually goes to black. Does this look even? All right, let's work on the shader now. Oops. I want that. Let's clean this up here. Get our debugging out. Okay, just clamping it at the moment. And that's just silliness here. Power should be like 0 to 0. If uv dot y. We basically have two halves now. We have the top half and the bottom half. So uv dot y, if that's less than or equal to 1, then we do one thing, otherwise do the other. Get rid of these. We should have two halves. I don't see two. Let's have power of 2 and 8. Let's make it more obvious. Should be the top half and the bottom half. Oh, they're all equal to 1. So if it is 1, there we go. There's the top half. Actually, if it's 0, then it's a top. Or, oh, these are gradients, right? So if it's less than or equal to 0.5, 0.51? Oh. Oh, not this again. I forgot about this. Because we can't rely on this just being perfect. Why is our Y so... That's strange. Let's go... No, top view. Wireframe. Because these get set here. The gradient's going from there to there. So if we go 0.5... Yeah, it's halfway between those. Alright, let's ignore Y. Even though we spent all that time on the test stuff. Okay. So power is going to be equal to... We definitely want to clamp it. Right, between 0 and... Well, 1 in this case for OpenGLES 2. Say power is equal to a clamp. So we have power. Okay. The clamp. Clamp, float, float. Yes, isn't that a float? Oh, no. I didn't see it. There's actually two values over there. There we go. Okay. Let's go to our world environment. Change our glow up. HDR threshold of 0.8 should be good. Give us a little glow. Okay. So we do have time. We're gonna have to do something with time. Graph toy. So that should just fluctuate. Let's just say divided by 2 plus a half. It's called the spot. Okay. Power is going to be equal to UV dot X minus spot. It's not quite right. You'll see. Good. That looks neat though. It's really, I think we want the actually what does that do in here? And yeah, by 2 pi. Actually, we don't even want that. Okay. So we take the mod. Now, basically, I want the distance between that and this. So if this is less than, I don't know, 0.05 or something like that, and then we set the power to 0. Absolute value of that. Okay. All right, now we just slow that down. Let's take the absolute off there. Yeah. Now, if I wanted it to go in a circle, we could try to get Y involved. Sam, actually, let's bump this up a little bit more. 6. Just playing with that a little bit. Okay. Slow it down a bit more. Huh. It's kind of neat. All right, now how do we use UVY? As we saw earlier, we're gonna have issues with this. Why? We do the same thing with Y that we're doing with X, with the 0 to 1, but from top to bottom. Well, let's go do that. Let's close Godot, save it, kill it. All right, now back to this. What is Y in this case? Y is going to be, let's see, in the top left quadrant, okay? So if we are in this top left quadrant here, then this will have to be, say this is going to be a 0 and this is going to be a 1. And it'll go around this way, 0 to 1, and it will also go around this way, 0 to 1. I'm basically going to have half track. What do we do here? Looks like we did half height plus the y. So y is going to be... So we do the same thing. We divide by half the track. We're basically just adding the width and height, but it's half the width minus the x. We have half track, half height. Yeah, see, we hadn't been planning on doing it this way. We should just have width and height. Let's fix that. Do we use center? Where do we use center? Oh, just to see which quadrant we're in. Okay, fine. Okay. Get rid of those. Looks like we also have half height here, so let's just do that as a height divided by 2. All right, now in this case, we were doing what? Half width minus the x. Because we start there, we have to, if they're already in the middle, then we have to take that away. So if they're like 0.5 or whatever we want to call this, 5. So if they're here, switch colors, if they're here, and that's at 5, and this is 10 wide, then we have to change that to 0. So it's that minus half a width. But what if they're here? What if they're here? And that's like 1. Yes, so half width minus whatever they give us. Okay. Half width minus that. That's good. And then we add the vert.y. This is y. Okay. Now quadrant 1, that's on the far right side. It's on the top right. So this section up here. Y is going to be equal to this divided by half track again. So it's going to be the vert dot, oops, minus half width plus, yeah, vert dot y. Because if they made it all the way across and then started to go down, yeah, that should work. All right, now quadrant 2, it's down here on the bottom right. So where's that? Where do we want that to be? Let y is equal to, yeah, this is where we start to subtract 1, or subtract from 1. Maybe. Either that or we just add it to half width. Because we're going top to bottom here. So we could just have their whole vert dot y. So negative vert dot y plus, they get a half width for free because they passed the top section, plus and then however far they actually traversed on the bottom, which should be a half width minus, oh, what is that? That's going to be, It's going to be the full width minus their x. We'll see. This is going to be a y. Same there. Let me start this for just a minute. So we have a half width. No. Okay, so we have the full width. I'm thinking about the bottom, right? So in this case, this section here, if they came this way, came all the way down, and then they're coming around the last little bit here towards 1. If they're right here, we'll have a full width minus that. Well, we want this value here, don't we? So it's going to be a full width minus their x. That works. Then we add whatever's remaining to a half width, the full height, and then the last little bit. Okay. Get a little better at it. We're going to... Oh, can we not inline this? What's our errors? Oh, expected 4, found 5. What else? Yeah, the other tests. The ones that we're ignoring. Let's ignore them harder. All right. Where do we go? Where do we go? Cannot find derive macro. Don't care. Okay. Last little bit. This one here. So in this case, they get a half track for free, divided by half track. Oh, I buffered. Ooh. Let's take a moment. I want to see what happened there. Just loading up the Starlink app. So split second on your end? Okay, well that's good. My phone's being a pill. Just gonna let it do its thing. It's gonna be the full height, so it's negative vert y. Let's vert.x. Because you go over, that's the bottom section. We had the half width at the top, and then it's just the y. Oh yeah, yeah it did. It just had a couple little blips actually. Still not too bad. It's been getting better and better and better. So here, let me show you. So up there, you can actually see the oops, there, those little dips there. Murphy, we took away the buffer system. That's gone now. So, I mean, we could turn it back on, but it's been doing really, really well today. It was going so well, and I just want to see. I mean, I might turn it on, but it would be for just like a second, right? The buffer would be only a second or two, maybe two. Not three, though. Three would just be unreasonable at this point. Okay, we should probably update the tests. This is going to be broken. We'll just see what the outputs are that the test gives us. See if it's sane. If it's not, then we'll fix it. All right, so here we have 0.6, and this is on line 642. Now, where are we? Here, this is... Hey, Bear Duda, how you doing, buddy? How are you? I hear myself. It just sounds funny now. Rough but okay. Oh, how's your head? Is it a headache? No delay nonsense? Oh, I know. I know. It's just too much. We can turn it back on if you need. You need that anticipation of the text showing up. All right, so this is the top left. And it wants to be 0.6. That's not right. That's wrong value. I think it should actually be this 1.6 value. And I got a mic. Check this out. I got a mic. Then I'm going to be using this mic for doing the audio recordings for the game. I'm looking forward to that. Having the children scream their heads off. Actually, I could just record them playing. Yeah. And cut out the shrieks and the shrills and use that in the game. He took my Batman, but replace Batman with something else, like, I don't know. Just dub it after the fact. Slice and dice the audio. What are we doing here? Trying to get this. This was 0.6. It shouldn't be 1.6. All right, this here. Yeah, I got the Y wrong. Divided by half track. Why are we? Yeah, it should be divided by half track. Oh. All right. Cable management issues. Should be negative or .y. I'll bet that's it. What? What? No. I mean, I didn't. That should have changed. We didn't change that, did we? Oh, I did. I collapsed these. I mean, we keep this. Mm, technically, this is wrong. This should be plus vert. No, I do not mean to be in big head mode still. Thank you. Thank you for that. We're gonna need to have some sort of heads up display for this. You like it? Just wear a green screen beanie. There we go. My boss at work, he's got a green screen suit, but he's got two different hoods. One where he just has his face available to see. Wait, what happened here? So this was x is equal to height, which is how, okay. That doesn't fix it, does it? Am I looking at the wrong thing? I'm fixing the wrong thing. No. When did this break? This should not be 0.34. We did not change the shape of this square, this rectangle. So that should not have changed. Oh. Vert UV. What's our height set to? Height. We are passing in width and height here, so center width height. We did change that. Is this different? Center width height. It's the same here. Half height is height divided by 2. Half width, width divided by 2. Is our old test actually wrong? It couldn't be. Okay, let's draw it out. We have a rectangle. 20 by 10. That's 20 wide. That's not draw. There we go. 20 and 10. And we're trying to analyze this point here. Starting on the inside track, by measuring from 0 to 1, which is over there. So in terms of units, this would be 4 units. This is 1 unit. This is 1 unit. So they would have gone a sixth of the way around the track. And 1 divided by 6 is 1.6. So we put x back to the way it was. That did not help. Half track, yada yada. Sorry, half track wrong? Oh, it is wrong. We shouldn't be divided by 2 there. Just 1 width and 1 height. There we go. Oh, perfect. Okay, now we've gone back to this point. 1 crisis averted. Check this out. We can inline these. Boom. Inline. It's all I had done before, and I was curious if that had screwed it up. Okay, but here... Now, in this case, we're basically doing the opposite thing. Where if you're in this quadrant... Right, let's use a different color. Let's use yellow. We're going this way around. From 0 to 1. And this point here... What is that? 6 units. This is actually 2/6. It's actually twice the value. So yeah, that 0.3 is correct. It's a third of the way around. All right. It's the top left corner. What's this one? Twice that, so 10 second buffer. Mine's not that long. Maybe it is. Oh, looks like, yeah, we had a little drop there. I think I might turn the buffer back on tomorrow. but it'll be short, maybe 3 seconds or so. So what do we have here? Yeah, we're still getting some packet loss here. It's not too bad though. Oh, point, I don't know, 7. Is that the same number? All right, what's this one? I don't know what it is. But as long as I've had this, it's only improved. So month on month, it's gotten better and better and better. So, in fact, I need to dig a trench because I got to bury some Cat 6 cables. Because I got the Starlink thing off the lawn and mounted it up higher on a building. I'm not looking forward to digging a trench. Bottom left corner. Just say 0 there. I'm not going to guess at those. Okay, those are already labeled. Now this one I think still fails. Time to pour some tea. Tea time. So we failed at 653. There we go. One and 0. What? Neither value. I was not expecting either value. 653. Bottom right corner. Oh, okay, I guess we were, right? Here's 0. The other one's providing a 1 because it's on the bottom. Wait. This one worked? Right corner worked first try? Oh, good job, us. I think this one is the one we laughed at. Let's try again. So if you are in quadrant 2, that means that you have already gone half width because you went across the top. Right? And so you're going this way, right? So you've gone across the top here. We'll give them that. And then we'll give them their full Y. So positive value for Y. And now we have to give them that last little bit. Last little bit on the bottom. So if they came back across in this direction, now I got to get that value. And what's that going to be? So we'll add something else to it. And this is going to be the width minus their X point. So if they're there, this is going to be 20. 20 minus, let's say 18. That'll be 2. Yeah, we just add that to that. Oh, that's hot. Ah, that is a correct value. I'm gonna copy that value. Where? Line 653. All right. Next one, bottom left corner. Should be the same, but we didn't update that yet. Come on, come on. Oh, that looks like a good value. It's just beyond half of center. Oh, you have exposed fiber to your house. That was pushed up by a neighbor's tree roots. Oh, wow. It must be in conduit, right? That big orange conduit? Wow. Cheapo Google Fiber micro trench solution? What? Oh, I've never heard of that. Just a black wrapped cable, fiber cable. Wow. Huh. I have not heard of that. All of the fiber around here is like in serious conduit. I can only imagine it so that when you cut into it and you see this bright orange cable, bright orange conduit, just shattered there on the ground, you know your life is going to be miserable for the next couple days. All right. I had a request for D&D tonight. That's working. You should go rebury it. Uh, Gonna switch this back to Gelios too. It builds, yes. Hmm. It's better now. Says look. And that looks okay. So now we should have an accurate 1 to 0 for a y. Let's extract this out to some other value. Let's say t. Float t is equal to that. So I'm going to say divided by 32. Leave that there for a minute. If uv dot y is less than or equal to 0.5, do one. Otherwise, do the other. I'm just going to want this to be 32. You know what? Oh, I'm doing Rust-like syntax there. I need the parens. I couldn't figure out why it wasn't working. Let me check on some stuff real quick. Then I lost my keyboard and mouse. Okay. Yeah, there was a giant mouse there for a minute, because if you shake your mouse and OS 10, you get that sort of accessibility feature. It helps you find it, but there. So as big as an unclutter just hides it for you. Hey, give me a minute. I have to check on some. All right, we're back. All right, so now that we have the Y, I was hoping to be able to like divide this by 2 so that like if it's less than 16, we do 1/2. If it's greater, we do the other. Hold on a sec. All right. Sorry, I got a little distracted there. Why do we do the mod T for one? Oh, because we divide by 32. So we make it wide, divide by that, then we get the spot. The spot goes from 0 to 1. Hmm. Change that back to 8 for a minute. Have that go around faster so we can watch it. This is going to be strange as it goes through. No, I should. Looking at the right side, because those are opposite. Interesting. I might actually change color. Huh. Okay. I'm going to do this the other way. So if uv dot y is less than 0.5, I would do the top. So this should only do the top half, yes? Yes. So basically we want to be able to control this here. Do we instead just do sine and cosine of spot? Because if we go to way over here, all right, sine of t, cosine of t. Oh, what's this one? They got some cool stuff down here. It's FMA. For, huh. Did I miss one? And, oh, it's less than. We need a compare. Oh, it flickered. Oh, look, look at this box over here. Okay. It's kind of floating around the box. Okay, that's not exactly what I wanted. Hey, Hefe. How you doing? So we have power. We're going to drop that to 0. And I think we don't want spot here. Do X and Y. So if we remove this F, what do we have? There. So we have our gradient going from 0 over here, following the track around to 1, both across the top and to the bottom for X, the UV dot X. And for UV dot Y, it goes from 0 up here to 1 here. Maybe we add... No, that wouldn't work. I mean, if we just had this, but how do we limit this? I only want 1 on there. Divided by 2.0 plus 0.5. Should keep it on there the whole time, but it's still the same thing. This is challenging. This is good. Yeah, it's like we really just want the mod of time. We don't really want that. It's going to be comma 1 dot 0. Because we have been using t here. Then it loops around. Good. I'm doing Vim again. All right. Let's call that I. So they don't need to be modified. Then we should be able to see if I is less than or equal to 1. And j is less than or equal to, oh, less than or equal to 1. 1.0. I gotta do the dot zeros on there. Isn't cosine always B? Um, always 0 to 1. I think. I don't know. They seem to be going between -1 and 1. All right. Good, good. Less than 0.0. That's really what I wanted. Because I just want a quadrant. All right. Which quadrant are we going to see first? They're never negative at the same time. I forgot about that. All right, let's. Okay, in that case, let's just have Q for quadrant and say that's going to be mod T 4.0. We'll have 4 quadrants. All right. Why is it always less than or equal to 1? Why? Oh, because we modded to 1 here. Duh. Okay. Okay, 2, 3, 4. And it's going to go through the whole sequence, isn't it? Yeah. All right. Sadly, I got to get off to my day gig. So we're going to work on this tomorrow. It's a good project for tomorrow. Um, who shall we raid? Dogglebit. Goodness, he's going right now. Classy cat. Oh, something in French. I discovered the Rust language. Um, all right. Stream for 2 more hours. He'll get on somewhere there. You can raid it. No, I would, but I can't. I can't. I wish I could. I'd like to. I'd like to be able to do this longer. Well, I gotta run, sadly. But I'll join the raid with you. What else we got to do today? I got to do work. Oh, you know what? We didn't do any of these today. We were just completely sidetracked with the whole mic thing. What do you tell a vegetable after it graduates from college? Congratulations. Till next time, y'all. Bye-bye. It's so bad.